it 2x squared,
plus 3x
okay,
minus 2.
okay,
And then it says use completion of the square to write this function in the form y equals a.
now, hang on, let's see, got the other form. Now, he says, Professor, we did some of these, we started out with this yesterday, and I realized there's lots of room for a mistake as you go through your work, so be careful. They call this guy's vertex form. They have in your textbook, it looks like this. Jonathan, see if I have that same form on the handout. They like to write like that in textbooks. A times x subtract h squared plus k. Now, they want me to put this black one that he gave me, function, into that red form. I gotta rewrite the black, still have the value, but rewritten differently. And he says, Professor, do it by completion of the square. And then therefore it's gonna look like the red, and they call this the vertex form. Now, before I jump in and start my work, this is where it's going to require some work. Guys, can anyone tell me, what would that A represent? Tell me anything about A that they're calling A there. That when I finally place this in that form, what is that A telling me right here in the red? Tell me anything about that A.
Vertical stretch.
Okay, vertical stretch by factor of whatever A is. Also, I love that, vertical stretch. Now, can you tell me also, if A is this, what are you guaranteed? It's going to open up. All these are parabolas today, so the graph's going to open up. Please tell me, guys, and put a comma there. If it opens up, the vertex, they call it the turning point, which we'll find here shortly, it's down here, point at which the graph changes from, let's say, decreasing to increasing. Looks like on the left it's falling, and all of a sudden it hits that point down there and it starts rising. So it changes from decreasing to increasing. They call that the vertex. And of course, we'll find it here shortly for this problem. Can you tell me anything else about the vertex, the way it's positioned? If the graph is opening up, the parabola is opening up, can you tell me anything else that may be true about the vertex?
That's the minimum.
That's the minimum. It's going to be the minimum value. So we put a comma here. In this case, I also have found this. And it so happens it's a local and an absolute, like we talked about earlier. So all that's going on. Now, if this happens, if A is less than 0, it's negative. Guys, we know now the parabola is going to open down. And if it opens down, we still have a turning point. They call it the vertex right here. And besides acting as a vertex, if it's going to open down, what else is it acting as?
Maximum.
Maximum in this case. All this work is coming together for us. We're about to close down chapter 2. It's a maximum. Now, should I consider A to be a 0? I consider less than 0 and greater than 0. Should I consider A to be a 0? No. If A is 0, what happens? The whole thing collapses. It drops out. If A is 0, there we have nothing. A 0. Okay, so I don't want that to happen. So A is greater than 0, A is less than 0, those two cases, max, min, and so forth and so on. Now, I'm looking at this. Jonathan, class, here's the question. 2x squared plus 3x minus 2 definitely is a quadratic. Now, I think our textbook calls it a standard form. The standard form, not vertex form, the vertex form is in the red. It looks like this. I'm gonna write mine like this. That's what my original black function that he gave me, it takes the form of that. That's a quadratic. Ax squared plus bx plus c, and all of a sudden, this in the red is also a quadratic, but it's in a different form. It's in what they call a vertex form, for a reason. You guys got to change from the green to the red. That's what it comes down to. You got to change from the green to the red today. Now, before I jump into it and start my work, I would love for someone, I don't think anyone can do it right now, but I'm going to throw it out there. Does anyone think, first, when I graph this, and I'll graph it eventually, will the parabola open up or down? It's gotta open up because the A out front's positive. So this is a positive 2, so the parabola's gotta open up. If it opens up, when I finally graph it, there must be a minimum. And we'll find it. All that's true right now. Can anyone tell me, right now, at this moment, where is that vertex located? Right there, for this particular quadratic.
You don't know.
I don't know myself. Leo, I saw that hand going up. Leo, do you know where that vertex is?
Yeah, I just shifted already in the vertex form.
Oh, whoa, okay. Oh, so you've already placed this thing in vertex form. You'll have to rewrite that black into the red. Because right now, I don't know myself. Where is that turning point located? We've got to find it. And guys, to find it, that's the issue. By completion of the square, I'm going to write this down. We're going to do this. Now this is where it gets tricky, and I mean tricky, and we've got to be very, 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 very careful on this. SMC sending me out notices already. Okay, now, does anyone know what I should do first? If I want to rewrite the black and make it look like the red.
Make the leading coefficient.
The leading coefficient must be a 1. So I'm going to jump over there right now. Right, this is y is equal to, I'm going to take out the 2. In other words, factor out the 2 on the x's, just the x's. And I know it's awkward, but we got that. And I'm going to show that I need to add something to complete the square. So I made that leading coefficient on the x squared 1, which it has to be if you intend to complete the square. Now keep in mind, there's still a minus 2 on the end, which I haven't touched. That was in the original. It's still there. Now, can anyone tell me what is required on that blank? In this case, to make this turn out to be a nice, and this is what's supposed to happen, this should turn into a nice, perfect square when I finish. What's going to take on the blank?
9/16.
1/2 of that previous coefficient, I think it's 3/4. Squared, 9/16. Now, hold on. Was that 9/16 up here anywhere at all? No. So I can't change my function, I'm just trying to rewrite it in a different form. So what happens is, you got a 9/16, but you also got 2 out front being distributed on that. So guys, what is 2 times 9/16? A little canceling. 9/8. Did you cancel 2 and 16 get an 8? So was that 9/8 there to begin with? No. So you say, well, hold on, Professor, it wasn't there, so I better do this to it right quickly. I'm squeeze in. Subtract 9/8. And believe it or not, right now at this point, I know it looks strange, all this mess, because you cleaned up, takes me right back to what Jonathan gave me up there. Does not look like it would. Do we agree?
Yeah.
It does not look like it would take me back to what Jonathan gave me. Not even to me. But it does. And with all those awkward little fractions, it says the same thing as originally what he did. Now, let's clean this up and see what happens here. Guys, this becomes in the green here, y is equal to, yes, I got a 2 there. Now, can anyone tell me what all this right here is? Should be a perfect square now.
X plus 3/4 squared.
That's all I want to hear. X plus 3/4, it's gotta be. Now, if you don't mind, we'll mark all this out. That's all done. It's done. Eric just gave you what it is. On the other end, they had a -2, which I kept in black. And then I had to put a -9/8 to cancel out my little work here. I got to put these two together, of course, with a common denominator of 8. Can anyone put those two fractions or two numbers together with a common denominator of 8 and tell me what you get?
-25/8.
-25/8 is what I want to hear. Please tell me. Is this now looking more like this?
Mhm.
But now I can invert it. vertex form. Now, Corey, you saw me the other day, I can't do it today. Even me, if I saw this, and you said, Ramsey, that's the same as this, I'd say, are you sure? Look how nice that looks up there with what, Jonathan gave me. Look at that, that's the original. I wrote it like that. And actually, they're equivalent. Except this one looks more awkward than this one. And I had to put the vertex form for a reason. Now guys, here goes. If I ask you from here, can you name the vertex, the turning point? Here we go. The turning point depends upon the shifts here. If you're going to graph this through transformations, what might that x plus 3/4 tell you to do if you were going to do it through transformations, which we're not? We're going to go directly to the graph here shortly. What would that x plus 3/4 tell you to do in terms of a transformation?
Horizontal shift
Horizontal shift, which direction?
to the left.
Now, so therefore, does it make sense if I'm trying to find the vertex, that I can quickly say, to the left 3/4, I can write that first coordinate I'm looking for the vertex, this turning point, as -3/4. Is that my horizontal shift?
Yeah.
It's gotta be shifted 3/4 to the left. That tells you quickly the first coordinate. Some students will go to that, Professor, can I just go ahead and set that green x plus 3/4 equal to 0 on the side of my paper and solve for x? You'll get -3/4. You can do that also. Can somebody tell me what do you think the y coordinate, because I need an x and a y to name that point. What do you think the y coordinate is? The vertical shift up or down?
-25.
There you go, it goes right here. That's the connection. There's my turning point. Awkward turning point, yes. So we've got a horizontal shift, and on the end tells me vertically, in this case, -25 over 8, if I'm doing it through transformations, vertically shift down 25 over 8. But we're not gonna do it through transformations. Guys, please follow. Don't mess up if you go through all this completion of the square and you get down to here, and I'm scoring a paper, I'm so happy. If we all get down to here, don't mess up afterwards. But I say, now name the vertex. Horizontal shift, vertical shift. It depends on these two numbers to name the coordinates. Making sense?
Yeah.
Okay. So now I know the turning point. And I know it should open up. We discussed that. This parabola opens up because of that. I got a 2 there. Wow. Now what else do you think I should find besides that? That might help me to get to the grid and graph this thing.
Your intercepts.
I need the intercepts. I'd like to know where does it cross the x-axis, where does it cross the y-axis, and we have it. Now, the x-intercept on the side here, guys, we squeeze it in somewhere on the side and write it. How does one find an x-intercept always, I don't care what the function looks like.
Set f of x
You
equals.
set f of x or y equal to 0. So go back and set f of x equal to 0, and you have this. This is a beautiful problem to open the class with. I'm hoping that quadratic will factor. If not, I'll use quadratic formula. It'll save me some time if it'll factor. I get 2x, x, I'm checking my work here, looks like maybe a +2 goes down here, and a -1 goes there. You guys do the factor, make sure my factoring is correct. I think it is. I think it factors. Split this up as we always do. If you solve this one, guys, you're going to end up with 1/2. That's no problem. I'm gonna write that as an ordered pair. 1/2 0 is on the x-axis. X-intercept. And if I solve this one, you're going to end up with a -2. And it, as an ordered pair, looks like that. So the test on Friday, 1 page. We'll be doing something like this. 1 page is devoted to this. Won't take that much room for just one problem on the test. Wow. Now, y-intercept. I find it before I get to the grid to graph this thing. Y-intercept, much easier to find. It's merely you go back and replace all the x's by 0. In other words, find f of 0. Guys, if I go back here in the black he gave me, replace all those x's by 0, quickly you can see what's coming out. If I replace those x's by 0. Is that -2? No problem. I prefer it like this, and it's on the y-axis. 0, down 2. There's my y-intercept. I have enough now to graph it. Mr. Park, do me a favor. I'm gonna go ahead and do this. I forgot my straight edge. I like to have my straight edge over here. Go over to my office and, if you don't mind. Yeah, here we go. You know the key, don't you? I think you know the key. Guys, we okay? Absolutely. It took a little work. Now, Hugo, if we were going through transformations, which we're not, this thing would take even more time, because you have to do what? You have to draw the parent graph, a simple parabola. Then you gotta show me it's gonna be vertically stretched by a factor of 2. There's another graph. And you gotta show me a horizontal shift to the left, 3/4. That's another graph. You gotta show it shifted to the left. And then that, finally, what? Is vertically shifted down 3 1/8. So you got a parent graph, probably 3 more graphs on top of that, on one grid. Remember those transformations? Now, they could get busy. That would be transformations. Jonathan, we're not doing that today. We're going directly to, with this count right here, directly to the graph. Directly to the graph. Now, the graph itself, what does it look like? Here we go. Let's get to this. Okay, guys, if you block here, wow, that was fast. Thank you. Okay, guys, I'm gonna plot the vertex first. I'm gonna plot in red. Here's my vertex. Turning point. So show me roughly, it's out -3/4 and down 3 1/8. Mark a few points here for reference. This is -1, let's say. And down 3 1/8. Mark it like this. So 1, 2, 3, 4. Got 4 there, guys. So roughly -3/4 down 3 1/8. It's gonna fall somewhere right in there. This is my vertex. In fact, I should label the coordinates there since I'm there. It's a -3/4. A -25/8. That's out of the way. The intercepts, let me see if I have enough markers here to work with. Let's pick up those x-intercepts. If we have no mistake, the x-intercepts are located at 1/2. Here we go. We're gonna put a reference here of 1, guys. This is 1. So there's 1 right here, an x-intercept at 1/2. I'll squeeze that in. And the other one's at -2. Let me stretch this out to a -2. Let's show the other one. Those are my x-intercepts. What else? Y-intercept is down at -2, which is right here. That's my y-intercept. This may be the same problem I worked yesterday. Okay. Now, is that enough with the blue and the red and the green going on there? Is that enough now to connect those and get that parabola? No problem. You say, Professor, my goodness, that's all there is to it? That's all there is to it. You want to just show me the parabolas opening up, passing through those points. Like that. Comes up. There's the graph. Done. Done. Now, what's the domain, guys? The extent of the axis, x-axis. What's the extent of this graph as you look at it? From left to right, the way it looks. What's it covering? What's the number?
All real numbers.
All real numbers. Right, like that. Or you could choose to do that. Now the range, be careful, the range is the up and down. How far down? That's the y. How far down is this thing drop? A -25/8. That's the minimum. And how high up does it go? Forever. Through infinity. So there's domain and range. Done. done your favor. Is there anything else I should ask if you have the graph in front of you? Looks nice. Required completion of the square. My concern is, I'm scared, when I start scoring papers on Friday, I'm scared if you mess up here, then everything can be messed up. So what I would do, this is me, I would, on my scratch paper on Friday, I would expand this thing out, clean it up. Actually clean this up, expand it out, x plus 3/4 something, x plus 3/4, do my business, and see if eventually, will that take me back to here? That's a check. If it does, you should feel good, this is correct. This vertex form is correct. And then you can just grab it. Guys, how's it look? That looks pretty good? Now, Corey, by the time you get into that Math 7 course, Hugo, what they're gonna ask you to do is, and Anna, Bart, they know for sure what's gonna happen here. They're gonna ask you to take a parabola of this sort maybe, and they'll say, oh yeah, you saw Ramsey do that in Math 2, and that was the easy part. And you'll say, well, it wasn't so easy when I saw Ramsey doing it. But what we're gonna do now in Math 7, but what they want you to do now is spin this around. In other words, push it behind the board and start spinning it. And form, don't do this in your notes, there's no preview copy. Take what you have, that parabola, and start spinning it and form a solid that looks something like this. Can you imagine this right here, this piece here being pushed behind the board? And it's like spinning around, around, around like that. Could we end up with something that looks like that, a solid? With that parabola spun around an axis and form a solid. And guess then what? Did you guys have to find what, maybe the volume? Good luck. If I see you on campus, spring semester, you're crying, I said, That's not what happened here. I thought I'd point that out. That's cute. That's what happened. Mr. Parker, remember these?
Mm-hmm.
Yes.
Could we do, if we have time, could we do the other one where it's pi x squared plus pi x plus 1 over
I'm getting there. I'm getting there. Okay. Now, this is beautiful. You have one of those, in fact, it's on the review right there, isn't it?
Yeah.
Okay.
It's actually,
Now, let me get into the next part, then I'll answer Eric's question. You said, Professor, for goodness sakes, I'm gonna take Johnson's problem one more time. I'm not gonna redo what we did, we're finished with this problem. 2x squared plus 3x minus 2. You say, I thought we were finished with it. We are. We got the domain, range, we got the graph, we did all the work, we complete the square. I bet everyone in class would love to know, Professor, is there some quick way to find this, the turning point, vertex, which is critical for a parabola, and not go through this completion of the square? That's the only thing I'm afraid on Friday I'm gonna mess up here with these, which will throw off this. Is there another way, Professor, to get to these numbers with those fractions and not have to go through that completion of the square? There is. There is. So how can I find that vertex and not go through that completion of the square, even though I'm gonna ask you to do at least one Friday with the completion of the square? What can I do? Now, I've got a clever class in here. Anna? Hart? And I'm gonna talk to you guys about, we're gonna start having small group work in class. So you guys will be busy. Down in the math lab, we're gonna start taking students down to the math lab.
I am busy.
Yeah, we're gonna be busy. We're gonna be
I'm really
busier.
busy.
I know, we're all staying busy. Now, here we go, guys. Bear with me. I will quickly just step in and say, Jonathan, can you tell me where the vertex is right now, and you had not seen all this work? I did not do it by completion of the square. I just gave it to you directly, and I come to you and said, Jonathan, where's the turning point? Or better yet, Jonathan, what is the minimum, where is it? What is the minimum value that this function takes on, no matter what you replace x by? This graph will get down to the lowest value of what? And since I have a graph, Jonathan's gonna say, Professor, the furthest it drops down is a negative 3 1/8. That's its minimum. I don't care what you replace x by, you'll never get a value lower than negative 3 1/8. And me as a instructor, that's striking because I thought, are you crazy? Yeah, I can replace x by any number I wish, rest of the class period. Up here, replace x by 10, by negative 12, square root 2, pi. I don't care what you replace it by. Crunch it out. Give me an answer. One thing I can guarantee you is, you will never get an answer below negative 3 1/8. I don't care what you replace x by. That's amazing that you can tell that from that graph. I don't care what you replace x by. You will not get a value lower than negative 3 1/8. Now, Jonathan, here we go. We'll start all over. I would like to go directly from here to there and bypass this. Bypass this. Professor, please show me, Professor. Bypass this and go directly to that vertex. Professor, is there a way to do it? There it is. So that's what I'd like to do in this second part. Show you a quick way to do it, which I'll allow on some of the problems on Friday. In fact, I think I threw on this handout also when I get to it, Jonathan. Ask you a few questions here. So guys, no completion of the square this time. Okay, so Professor, what are you going to do? Now, this is where I need your help. I'm going to go back to the green standard form for a parabola. Right like this. Or quadratic. All quadratics look like that. We all know that. We know what they look like. Not going to complete this square any longer after I go through this though. Now, Leo, if I should ask you though to take the green, ax squared plus bx plus c, and do me a favor to lead me to where I want to go, do complete the square on it. Because I want to see what a result falls out, which is going to be a big help. Wait till you see what falls out. Now, guys, I need some big time help. Suppose you're asked to complete the square one more time on this. Now, can someone tell me, and I don't want to look awkward, I've already completed the square on this one over here. What would be the first thing that you'd say, Professor, you gotta do, like we did over there? Even though it's a little strange to say it, but I gotta do it. What's the first thing I would have to do on that green if I want to put it in vertex form?
Factor out A.
Gotta factor out A. You're gonna make that leading coefficient a 1. I think back on mine, I factored out a 2. Now you're gonna factor out an A. Watch what's gonna happen. You're gonna be shocked. On the axis. And be careful guys, we'll get something strange inside there. I'll put a blank to show I need to complete the square. I've still got plus C, I'll put it down here. Hang it on. Divide everything by A. B over A is the best I can do. Okay. Can anyone tell me what's it going to take on that blank? Back here, it was, where am I? I did almost, right here. It was 9 over 16. Now, can someone venture out and tell me, even though it's going to look strange, what is on the blank here?
1 over 2b squared.
So again.
1 over 2 times b squared.
Ooh, Eric, I
B
think you might
divided
have.
by 2 squared.
Okay, divide by 2, we'll take 1/2 of, in this case back here, guys, I took 1/2 of what? 1/2 of 3/2, about 3/4. And then squared, that's how I got that. If I do it here, even though it looks strange, he's telling me, Professor, you gotta take 1/2 of that. B over A. I don't have a number here, so 1/2 of B over A, you gotta do that first, Professor. Well, that's gonna give me what? B over 2A. Put a comma, and what did I do with it afterwards back here? You got squared. That's how I got that 9, was it 9 over 16? Yeah, 9 over 16, got squared. Now if I take that b over 2a, strange as you know what, got squared. And I'm gonna end up with b squared over 4a squared. Get ready. That goes here. Cute. B squared over 4a squared. Now, was that originally, Jonathan, was that originally in the green here to begin with? Was that listed up here to begin with? No, so I gotta take it out like I did over here. Now be careful, guys, I'm going to take out what I need to take out. I put this strange thing in for a reason, to complete the square. There is an a out front, like there was a number out front of mine. If I distribute the a on b squared over 4a squared, this times this, what does that give you right there? Who has an idea? A times b squared over 4a squared. It looks like this. Distribute property. Could I write it, and see if you guys will agree, could I rewrite it like that? Where one of those a's cancel. Can I do that? Like over here, I think what I did when I did it, I went, where was I here? I got, okay, 1/2, and then we multiplied 2 by that, absolutely. Yeah, I multiplied this times, oh, this times this. 2 times 9 over 16, I cancel 2 and 16, that's how I got that 9 over 8. This time, same process, but I got something strange. I got, if it's okay there, Eric, you remember anything about the same thing there? I got, b squared over 4a. The truth? What do you think I'll have to immediately do though to take it out? Because it was not originally there, subtract it. So now let's put a subtract b squared over 4a. Much like the problem over here, except you got letters to work with, variables. Same process though. Now let's see what's going to happen here. Now you're going to end up with y is equal to, hey guys, if all my work is correct here, let's stick with the green. Please tell me what on earth is all that in the parentheses. It should be a nice perfect square, like back here it came out to be x plus 3/4.
Would it be x plus b over 2a squared?
Love it, love it. It's gotta be x plus b over 2a. It's gotta be. Here's x plus 3/4. Same process. Now how did I get back over here my number negative 25 over 8? I put these two together on the end, and that's how I got back over there the negative 25 over 8. I gotta do the same thing here. I know it's gonna look crazy. Does anyone think they know what it is if we put those two together, the red and the green, with a common denominator of 4a?
Is that 4a times c?
Come on, tell you again.
4ab squared over 4ac?
We're getting close.
4a minus b.
We're getting close. We're gonna put the red and the green together with a common denominator. Guys, think of that c as c over 1 if you wish. If I want a common denominator of 4a and put them together with a 4a.
4ac.
Yeah, I have to multiply this by 4a. Now, what would be a good way to express, now those now have the same denominator. What would be a good way to express those put together with a 4a common denominator?
4a times c minus b squared.
4ac minus what? b squared. Or if you want to write backwards, negative b squared plus 4ac. Vanessa, I like what you're saying there. 4ac, is it? Do you want that first? Minus b squared all over the common denominator, 4a. Oh, 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 oh. Guys, here's the one I did earlier, which you'll love when you see it on the exam. You got numbers to work with. All of a sudden, I redid it, not redid, I did the function, quadratic function, without numbers. but I use the same process I did over here, and got something really awkward to work with. And I'm gonna stop right now, your textbook gives this as your form. This is now in vertex form. It's in vertex form. Leo,
Just a question regarding the
go
exam.
for it.
Would this, would you give us a question like this on the exam where we?
No, I'm showing you the derivation. Your professor's showing you where it came from. Now, some professors may just come in and just give you a formula and say, hey, guys, plug in the numbers into the formula, get an answer, and they smile, he smiles, she smiles, you smile, everybody's happy. Well, where'd that formula come from? That's the math. That's why, no, I'll show you the derivation, where it came from. It's like a formula now. Now, if it is, be careful. Can anyone tell me, I know it's gonna look strange. Back here, when I got down to this point, you guys quickly said, Professor, that's a horizontal shift to the left. He wrote it as -3/4. And then this, Professor, right here, is my vertical shift down. And I wrote it like that, and I had the coordinates. I knew exactly where my vertex is located. Can anyone tell me, based on what you see here, this would represent a horizontal shift to the left of what?
B over 2A.
Is it thinking negative? Negative what?
Negative E over 2A.
That's like the other part, right here, they match up. So what should the other part, which is going to act as a y coordinate, be? It's one of the strangers, you know what? What's my y coordinate here?
4AC.
4AC, oh my
minus
God,
B.
4AC minus
B squared.
b squared all over
4A.
4a. Now, through my derivation. Well, who's asking about this? Leo? Were you the one asking about? Yeah, no, that's my derivation. I would not ask you to derive this unless you were in an honors scholars class. Yeah, okay, no, that I'll derive it for you. Now, what I discovered, if I don't say do completion of the square in my test on Friday, and I forget to use the word completion of the square, and I ask you to find the vertex, you can go directly to this. It's a formula. Now, I'm gonna go directly to this right now, and first I'm gonna check it first, though, and then take questions. Guys, let's go back to what Jonathan gave me this.
Yep.
Now, suppose I say, Jonathan, let's not do this. That completion of the square and those strange looking numbers there, I'm afraid we'll mess up somewhere with those fractions, Professor. I'm gonna just mess it up. Well, if I do not insist you use completion of the square, then the vertex quickly would be, here it goes. First it says negative b over 2a. You said, Professor, what's that? Well, that's this. This is b, this is a, this is c. So in my case, be a negative, and b in this case was a 3 he gave me, over what? 2 times a, is a 2, by the way? Help me out.
Yeah, A is 2. Yeah.
Is that negative b over 2a?
Yes.
Is that negative 3/4? Did we get negative 3/4 down here after all that work and we're wiped out, worn out? There's negative 3. I know you're getting excited. Hang on. Don't take questions here. Now let's try to find the second coordinate. Leo, if I've made no mistake, and sometimes I will make a little tiny mistake, but not many. Here we go. It should be, if I want to use the formula, this business here. Okay, let's plug in, see if it is. This would be now 4. Back there it says what by formula? A is 2 he gave me. C was negative 2. Got that. Subtract b squared, that's 3 squared. All over 4 times a, 4 times 2. That's what the formula says it should be. Close that up. Now let's check. Now, woo, Randy, I hope you're okay, because when you do all that crunching of those numbers and simplify, you had better get that you got earlier. Let's see if I do. Guys, this out front here, I think is, help me out, is that a negative 16? and it says subtract 9. Is that negative 25?
Yep.
And what's the bottom part, 2 times 4? Oh. Oh. Gee. I'm gonna take questions. Now, before I take questions, I got some hands went up already. That's why I love teaching this class. I guarantee you, if I ask in class, guys, would you rather use that formula to find this turning point called the vertex rather than going through this?
100%.
Just go ahead and use the formula. And I showed you where the formula came from. All you have to know is the formula. Now, before I take questions, can anyone in this clever class tell me, just one more little thing here. Is there even a shorter cut? Because right here, even myself, if I see 4ac minus b squared over 4a, and I know it's a formula, I gotta memorize it. I confuse it sometimes because another one says b squared minus 4ac in the quadratic formula, right? And sometimes I'll go, oh, this one's backwards, which it is. But sometimes I'll confuse it with b squared minus 4ac and it throw me off a little bit. Does anyone think they know another way to find, here we go, this, maybe without using the 4ac minus b squared over 4a, even though it works? Is there another way to find the negative, what was it, negative 25 over 8? Maybe without using the 4ac minus b squared business.
Didn't it c minus b squared?
No, something easier.
Or negative b squared?
Easier. Now, if you guys like formulas, go for it. That 4ac minus b squared over 4a is always going to work. Some students love formulas. Just memorize your formula. Memorize your formula. But can anyone tell me another clever way to get that right there and maybe not use this, even though it always works? Now, come on now. Come on now. Uh-oh. Eric.
Could you find the range of the function?
Ooh, easier than that. We're not going to do range yet. Easier than that. Here we go. Is there any, you got any ideas of how to find negative 25 over 8 without using this? You know, I can use this formula. You can use this formula. But there is another way, just in case you might want to do it. And sometimes it's a little shorter than the 4ac business. Does anyone think they know what it is?
Does it somehow involve plugging in whatever you find for?
If this is the x, which came out to be that, and you're looking for the y, and I know the y is determined by this formula, which you can use. Now, if you wish, you say, wait, Professor, after I find the x, can I just merely take f of that? Whatever that was. You know, do what? Just take my what, negative 3/4 back here, and go back to my original black function he gave me, replace, and find what the y is. That's why I think the y up here somewhere. I did. I could go back to the original black function he gave me right here. I will do it right here. F of, and guys, in my case, this is negative 3/4, so watch what happens here. Jonathan, you give me this. 2 times negative 3/4, what, squared? Plus 3 times negative 3/4. And subtract 2. Breaks all that. So that's what the black would look like if I replaced x by negative 3/4. That's what x was, wasn't it?
Yeah.
Okay. Calculation. That's 2 times 9 over 16. I'll come back to it. Minus 9 over 4. Subtract 2. Just doing arithmetic. Cancel 2 into 16. Make that an 8. So that's 9 over 8. Subtract 9 over 4. Subtract 2. Let's put all that with a common denominator of what here, guys? 8. So let's write this as 9 over 8 minus 18 over 8 minus 16 over 8. I did it quickly. I think, I'm going to check and see if I got that right. Okay. 9 over 4. I think it's correct, guys. Is everything in terms of 8 now? Let's put all my numbers in terms of 8. Put all that together, I think it is added up, I see a -9, -25 on top over the common denominator of 8. Is that what we got here? So if you don't like the 4AC, plug in directly. Now you're the same Y coordinates you're looking for. Now we'll take tons of questions. Woo, my.
I'm having a hard time understanding why the x minus h, why when it's positive we move left.
Oh, beautiful. Look at this, look at this. When we did, I'm trying to think what we did do. Yes. Way back when I did something like this, in fact, you saw something like this, I think, on the last exam. Martha, good question here. If I saw this, and I asked you to do it through transformations, you said, Professor, that means reflection through the x-axis, which we did. What did this say to do back then? What did the x plus 5 underneath there intend for you to do even back then? A horizontal shift to the left. Right? And I represent that to the left with a negative. That's where that came from. That negative b over 2a.
But why?
Uh,
Because I guess like in my mind I can rationalize if it's a negative, then the negative is squared and it becomes positive, so we move right, but.
You could think of it like that. There's still x plus 5. I don't know whether that would answer your question about why that came out to be a negative b over 2a. I think it's your question of why in all that work, Professor, did that come out to be and all this work with the formula? Where was it? This right here. Guys, by the way, does that plus sign indicate it is going to the left? A horizontal shift to the left, and I'm gonna write to the left with a negative sign.
No, right, I guess, but if it's positive in the formula, then why?
She's just asking, like, literally, why is it shifted to the left?
Oh, right here. You could rewrite it if you wish. Like that. That's still x plus b over 2a. Now, if that would help you to see why it should be a negative b over 2a, it might. So this part right here is there. Oh, I got another thing. Here's another way. If you don't quite see it either way, some students will do this. It's not much. Take the green. Say, Professor, I'm gonna go take that green and set it equal to 0, almost like finding a critical number, and solve for x. Take the green, set it equal to 0, and solve for x, and you'll get negative b over 2a.
Okay, that's it, yeah.
That's another way to do it. Love that question. Leo, what was that question?
It was just, can we just take your vertex formula and just have it as a check after you do that?
Absolutely. Absolutely. After you finish it up, you say, Professor, you made me do this by completion of the square. I took the whole sheet of paper, Professor, on the test Friday. I went through all this business, Professor. I'm not very good at fractions. I'm afraid I messed up. After you finish it up, he says, redo it with this process, with the formula, and so to get the same answer. Now, what have I had students do in the past? Well, I'm too good, though. I've been around too long. What have they done? They do this first. Then they see what numbers are coming out, and they make them fit over here. Even though their little business over here makes no sense, all of a sudden I see, oh, wow, that's nice. You know, look on the paper, I see on the side that they didn't erase it. They did it first doing this. And Jonathan, they took them back into the completion of the square and made it work. Yeah, go try that. Okay, guys, pretty good? So now you have a way to come up with the vertex fairly quickly. Yeah.
So is this technically just the vertex form of the parabola? And I know it's like the C in this case, would that be considered, I know there was like I read it somewhere, but they consider it E as well, right? Is that the
Not
same?
E, no.
No E's?
No, there's no
E's.
E there. Don't go to the E, chapter 4.
Got it, okay.
Guys, make sense? Absolutely. Now, please, after all that effort, if you're seeing this, you say, Professor, I feel pretty good about this. If you allow me to do this, which I will, I'll let you use the formula, which came out to be this. This is your formula. I'll allow you to use this on some problem. I'll have at least one where it's going to take maybe a sheet of paper. But you got to do completion of the square. Now, after all that effort, here's some questions I got. Domain, range, you guys answer that for me. Now, don't miss this now. I missed this yesterday. There is no way that after all that hard work, if on the side, all of a sudden you say, oh my goodness, this will take 4 hours, because all of a sudden I'm asking this. Here's what he gave me. Jonathan was -2, yep, -2. And you got that. You say, oh no, now he's into a quadratic inequality. That's where I gotta use sign analysis. Do you really have to use sign analysis on this one? No, you've got the graph staring at you. If you know how to read the graph, what's this say right here? You want the graph. This is what this is. This is the graph right there. That's quadratic. That's it right there. You want to know when is it above 0? That's what greater than 0 means. When is it above 0? In other words, when is it above the x-axis? And if I shade, please tell me, is this piece of the black graph above the x-axis?
Yes.
And is this piece above the x-axis? Now, you tell me when that's happening, you've got the answer for that quadratic inequality, and no sign analysis needed. Anyone tell me on the left, when's that taking place?
Open -2, or open negative infinity, sorry.
Over to what, negative,
-2.
2?
Open.
Got you. Open, thank you, union.
Union, open, 1/2.
It is 1/2.
To infinity.
Look at that. Then you walk out here and talk about this outside. I hear some of you guys out there talking about the test after you leave. And sometimes students will come back to me before I leave the room and say, Professor, what's the answer on that one? And then those 3 students who were talking about it outside, they all 3 come in, Professor, I can't go home until you tell me the answer. And one student said, I got 1.5, Professor, is that right? No. Johnson said, I got -2, is that right? No. And the third student says, I got the answer, no. Have a good weekend, guys. All 3 of you missed it. But I hear you talking out there. Now, don't do this. I know what you do. If you jump in and you factor this and you sign analysis like you did on the last test, and you'll get the same answer. But why go through that if you have the graph in front of you? You don't have to go through sign analysis. Okay, we'll close this down here shortly. Leo.
Sorry, going back all the way to the inequality, when do you have 3 answers? Like, what?
3 critical numbers?
Yeah, 3.
Yeah, hold on. You're taking me right into chapter 3. You're taking me right into chapter 3. I'll make it one real quick. It might look like that. That's a cubic. I can't do this business on that. This is only for quadratics. Now though, what could I do though?
Let you equalize.
I could still do something with it, I just can't apply this. What you could do is factor out the x. There you go, you're asking, x squared minus 2x, what, minus 3? You could do that. And then you could factor further into x subtract 3 times what? X plus 1, is that true? This is chapter 3. And then do what to get a graph? You can't do that. It's not a parabola. Yeah, you want to get your critical numbers and you sign analysis and draw up or down or above the x-axis or below the x-axis. I think I showed you guys one of those. And that's the graph. But it's a different graph than that. This is only for parabolas. Quadratics only. Don't try to use negative b over 2a on that. It works only for x squared. Quadratics. Okay? Making sense, guys? Now, Jonathan, do me a favor. Beautiful lesson there. See on that handout, they all have a copy now. I think they do. Anna, do we have some left over? Jonathan, did you have some left over here? When you guys
I
finish
give
math
away-
one?
No, I gave.
Like
Oh,
all
right here,
of
I think I
the-
got a few.
Yeah, that's one.
Does it say preparing for exam 2?
Yeah, and the other end is 2.6.
Oh, goodness gracious.
That's the one.
You did not get a copy. Okay. Jonathan, tell me on that handout now.
Yep.
Is there a part there where it says, which will be like on the test, is there a part now that says find the max or min without wrapping or without something?
Yep.
Please tell me what that is, and then I'm gonna slow down a little here and get this done. Hang on, guys, this is beautiful. This is absolutely beautiful. If you don't enjoy math, you better sit yourself down and say, there's something wrong with me. There's something wrong with me. Why am I not enjoying this math? I love negative b over 2a. Why am I not enjoying negative b over 2a? What is going on? Okay, part 2. Jonathan?
Yep.
They have their handout. Please tell me, read the directions for that part that I'm talking about.
Yep, so it says, without graphing, name the maximum or minimum value of the given function.
Okay, now watch how easy this is going to be on the test. Name the first example.
So the first example is f of x equals negative 2x squared minus 3x plus 2.
Let's do. I'm not going to ask you to graph that. And by the way, I know though, since the a is a negative, it's going to be a parabola, it's quadratic. I do know, I'm not going to ask you to graph it, but it does take that shape there, doesn't it? It opens down. So therefore, am I talking about a max or a min that they're asking me to find? A max. They're asking me to find the maximum value that this function takes on. Can you tell me, guys, what you just need to do? I notice that I did not say complete the square, I didn't mention anything at all. Would that be the best thing to do? Turn to this?
Yeah.
Now, are you going to use negative b over 2a? You want to do that first, then use the other part, or should I go directly to something else? What would be wise to do? You want to use the whole thing? You could. Okay, here goes. The x back there should be, here we go, negative b over 2a. That's what the x is, always. There it is. If I plug in here, I got negative, and b in this case is negative 3. 2 times a, negative 2. If I put that in correctly, I think I did. Guys, with all those negatives floating around there, I think it's a negative 3 over 4, is it? Someone check me out there. I think it is. Negative 3/4? Okay. Now I'm looking for the maximum value. Should I turn my paper in now and feel good? If it's worded, find the maximum value. Have I found the maximum value yet? No, that's the y value. That's one that goes up. The y tells me how far up it may go. So I now need to find that. Now, if you want to use the formula, you could go to that directly without using the negative b over 2a. Or, Jonathan, since I have it, negative b over 2a is negative 3/4, you can take this back and plug in, and you'll get the answer we're looking for. Or you could have gone directly here, and you'll get the same answer. Which one would you guys like to do?
Plug in.
You want to plug it in? Okay, here we go. Okay, let's try to find f of negative 3/4. No problem. Negative 2, negative 3/4 squared. Subtract 3 times the negative 3/4 plus 2. A little risky, but with fractions. Here we go, negative 2. You squared that, that's 9 over 16. I'll come back to it. Next, we'll end up with a plus, and guys, this is going to be a 9 over 4. Just doing some math there. Plus 2. In the middle is 3 times 3, 9 over 4. Cancel over here, this becomes a negative 9 over 8. I cancel 2 into 16. Of course, I got plus 9 over 4. And I hope I do not make a mistake. Let's put all those together for a final answer with a common denominator of 8. So guys, here goes. Negative 9 over 8 All right, the next one is 18/8. And that 2 on the end, I think it was 2, what is that, 16/8. Everything's over 8 now. Let's step back and look at it, see if you guys agree. Oh, boy. I think, okay. Add all that up, guys, help me out. If you add this up, of course, it's over 8. And what is that? See, negative 9 plus 18, that's 9 plus 16, is that 25? Oh, there's that 3 1/8 again. Was that, right there, much like what you originally gave me back here? With signs changed a little bit. Okay. So that's the, maximum value, 3 1/8, it's a max in this case. That's the maximum value that this function will take on. Now, Eric, before I take a question, I'm gonna get to you right now. Could I have gone right here directly to this and had found that 3 1/8 without going through the negative b over 2a first? So it's entirely up to you. So you could go right there, crunch it out, and you had better get, if I have no mistake, at 25/8 again. Okay, Eric, what's that question?
I was just gonna ask on a test, do you want the coordinates of the maximum, or do you just want the y?
You know what, if you go through and find the full coordinates, I'll give you credit, but if I say if it's phrased find the maximum, all we're looking for is the y value. I would need to see that negative b over 2a. The y value, so if it's phrased find the maximum in, you're just asking to find the y. If you want to go ahead and use negative b over 2a and find that first in, plug it in to find the answer, go for it. Or go directly to here, that is the y. Plug in, and you'll get it directly. Okay, that's on another hand go out. Mom,
I figured it out.
you got it? Okay. Got anything else? Is all this clicking now? To a full extent. Okay, it should be making sense, right?
Yep.
Okay,
It's just the opposite of start.
okay. Now, I'm looking at my time here. We're gonna finish up chapter 2 here shortly. John, you've been a big help. Would you now jump down to what's another part on that handout asking me to do?
It's, another function, but this time it's, oh, or you mean next
Yeah,
one?
another whole, entire part.
Oh, determine the domain of the following functions?
Yeah, determine the domain of the following functions. Now, hang on. I'm gonna call this part B. Name the first function where we actually find the domain.
So, it says f of x equals, we have a radicand, so it's x squared plus 3x minus 10.
We did that before. I think you even had one of these on the test. But they'll bring it back up again. So guys, to find the domain, that's all he's asking for here. You said, Professor, how does this relate to what you're doing today? Here's the way it relates. This part for a square root, for that square root to make sense, to be defined, must be this. You can't do a square root on a negative unless you're going to do imaginary numbers. We got, agree guys? All that's gonna be positive underneath there. This will factor. Thank goodness. Here we go. Step back and look at it, looks like it factors. Now tell me what you might wanna do that we've done so many times in this class. If you will find, and we'll finish up the inequality.
Sign out.
Sign analysis. So you would go quickly to your critical numbers. In this case, it's -5, a +2. They can't be included. Guys, we've done sign analysis so much, you let me just step back and see if I find what is gonna work. Guys, it looks like it's gonna be out here, you test later. We've done these so many times. Out here's gonna work. And there's sign analysis, therefore this answer is -infinity up to what, -5? Bracket. Union, and this one says, bracket, 2 through infinity. You're done. Finished. Beautiful. Now, we'll use a different marker. Can I have need a volunteer. Can I have a student now to take what was asked? We got the answer, we're finished, that's the domain. Can I have a student now to come up here and use a green marker on my grid where I use sign analysis and now illustrate what I was doing over here? I don't want you to complete the square, none of that business. I just want you to show me just on the green with the green marker. Go back to my straight line where I did my sign analysis. We got the answers. But show me how's that connect with what we're doing here. I need that connection. Now, I'm not talking about completion of square. Okay, so we're gonna just come back and mark in green on where I was doing my work. Show me the connection to what we're doing here. There's gotta be a connection to math. Somehow it connects back to here. Who has an idea?
Do you show the graphs
Like what?
with the, I don't know, the representation of the square root?
Nope. Oh, I got you. Nope. Oh, I see what you're thinking. Something else that connects with what we're doing right now over there. And I see it staring at me right on the board. What I want is staring at me. Oh, who said that? Eric, come on up. You don't mind, do you?
Not really.
Oh, come on.
I don't really know.
Oh, yeah, you do. Okay, I go to where I stopped over there where I was doing my testing and show me the connection with that by drawing a figure there. Show me what can you do, draw it in green and make it relate to what we were doing earlier.
Well, if it's a square root function, it'll look like.
Oh, beautiful, that's what I love that you guys are clever. Now I don't want that. I want it to connect to I've been talking about parabolas all morning.
Oh, well, that would be those would be the x-intercepts and then it would be.
Those are the x-intercepts on that parabola. So if you draw a parabola, do me a favor since you're here. Go ahead and show them. So when you draw a parabola, it opens up. That's its x-intercept. There it is. That's the connection. I asked you to do sign analysis. I've never asked you to go ahead and draw the parabola that represents all this business. It's the parabola opening up. That's all I wanted to see.
So then these would be the x-intercepts for this.
Okay, now hang on. Oh, I see what you're saying. Now show them, since I have the answer, shade in on the green parabola. When does that happen? Shade in on right on the green. When does that happen? There you go. And look at that. And those are the answers. Thank you. That's all I want. That's all I want. Eric, I know what you guys are thinking. You were thinking about that square root graph. You could do something with it. But I was trying to tie it in with the parabola. Since I talked about parabolas.
But that would be a square root graph though, right?
Well, the square root graph looks like this. Oh, yeah. Oh, yeah, this right here?
Yeah.
Somehow you gotta get that going on.
Okay.
You remember how that square root graph looked? But to make it connect to today, I thought, well, just go ahead and draw a parabola like we did, opening up, passes through those 2 points, and there's your parabola. And it even has a minimum down here. We don't need it. There's a minimum down here that you can find by using that negative b over 2a business, 4ac minus b squared business. You can do that. Everything connects. Okay. I got 10 minutes. Then we're supposed to take a break. Jonathan? Did they ask me to do anything else? By the way, guys, we got the, in this case, the max to b. Where was it? Final answer is this. That's the answer of that problem on your handout. That's the maximum value. Okay, what else is on the handout?
It just says, you wanna go to the next section, or?
Yeah, go to the next section. I'm interested to see what's
So the next section just says applications, find maximum height, time to reach this height.
Oh my goodness, we're getting close to closing down chapter 2 and I got 10 minutes. Anna, Park, here goes. I'm gonna do it in 10 minutes, at least one of them. Guys, flip your paper over. I should have a couple of application problems on the back. Shouldn't I? Okay. Jonathan, you've read so much for me, I can get someone else to read if you're okay. You're okay.
I'll read it.
Was you the one about the ball being tossed up or something being tossed up in the air?
Thrown upward from the top of the building?
Then maybe for that first test of yours, you were tossed up in the air and said, woo, I'm gonna get rid of that test. Tossed up in the air. Okay, read that to me.
Wait, is it the stone problem?
The stone problem.
Okay,
Something's being tossed up in the air. Okay, what was it?
so a stone is thrown upward from the top of the building. Its height in feet above the ground.
Okay, hang on, let me get on top of the building first. Okay, we got a building going on here. And we're saying, okay, Professor. I'm on top of this building. And for some reason, I'm on top of the building, I'm gonna toss a stone from the top. Eventually, neglecting air resistance and the gravity and all that business, it hopefully will take the shape of a parabola, which we're talking about today. Okay. Now, did they give me, since I got a parabola, they should have given me a quadratic.
Yeah, it did.
Okay, what was it?
So it says above the ground after 2 seconds is given by h of t equals negative t squared. I mean, negative 16t.
T squared.
Plus 48t, plus 32.
Plus 32. Now, you guys who have a little physics in your background, or you intend to do a little physics, you more than likely realize what those numbers mean. I'm not concerned about what they mean in that motion problem, height problem. Some students may say, Professor, I sort of recall what that negative 16 meant back then, and what the 48 meant, and what the 32 meant. Does anyone know what the negative 16 was back in physics? Anybody have physics? We'll talk about that. Yeah, it has something to do with gravity, the negative 16 does. And the 48 has something to do with velocity. As I'm throwing that stone up in the air at a certain velocity. So I got gravity working on it, a velocity, and then guess what the 32 means? The height of the building. Okay, so h for height, h of t, t is time. Okay, so rather than f of x, still got a function. This is time. And I'm just do a little bit with it, then we'll take a break. And this is height. Now, Jonathan, read the first part to me.
So, do you want me to read the first part from where I started, or the following?
Yeah,
place?
read the rest of it.
Okay, so it says, what is the maximum height reached by the stone?
Stop right there. That's all we'll do, and then we'll take a break. We'll finish it up after the break. What is the maximum height? And I know common sense tells me there is gonna be a maximum in here somewhere. There's gonna be a maximum height. Sort of like it stops up there somewhere, it's gonna fall back. They want to know what is that maximum height, I guess, measured from the ground, okay? Was that the way it's phrased, just find the maximum height, just that?
Yes, it says, what is the maximum height reached by the stone? And then the next question is, how many
Ooh,
seconds?
okay, let's stick with the first one, find the maximum height. Guys, we'll be right quick before we take a break. How does this relate to what I've been doing all morning, afternoon?
Maximum.
Leo, tell me what's going on.
Find the vertex.
You're going to find the vertex. That is the vertex. That is the vertex. Now, do I want to go back and divide or multiply or take out a negative 16 and complete the square of this mess? I don't. I'm going here. Where was it? I guess I'm going somewhere. Here. So we'll find the answer here. Vertex formula. Now, since they asked for what is the maximum height, that's the y. I don't really need this right now, unless you want to find it, which may answer something else later on, but can I go directly here to find the maximum height? Let's try it, guys. 4a was negative 16. C, where was it? 32, oh, my goodness, awkward numbers. Subtract 48 squared all over, what was it? 4a. Oh my goodness. let's make sure at least put those numbers in correctly. Opposite, you know what? 4AC minus B squared. Guys, did I put them in at least correctly? Oh, no. We can do it. We got a break here coming up in minutes. Oh, no, I don't even want to square 48 myself today.
Dividing may have been easier.
Right? I know. Corey, what's an alternative? How can I find an answer? We got set up perfectly, you get full credit to put that on the test. But would ask you also to crunch it out. Is there another approach I could take that maybe might be a little bit easier to get me to work?
Negative b over 2a and then plug in f of your x.
In other words, now go back and maybe find that first. Right? Now that's the x. Now, by the way, in this case, I think the x is like the t.